Yo, what is up, guys? We're back. Another video. I think this is episode 41, maybe, or 42. Honestly, I can't really remember. 42. Little update. Went out last night with my friends, so that was pretty fun. I do not feel good, to be honest. I feel kind of shitty. But the grind don't stop. So I decided to make another video. I don't think there will be as much thinking involved in the video. And what I mean by that is I don't think we're going to do like any crazy problems or whatever. We're just kind of going to scratch the surface a little bit, maybe do a few easy problems and call it a day. So I think that's the plan. But yeah, a little tired, man. Kind of don't feel well. I have a headache as well. So yeah, we're gonna get into it though. So I think we're at episode 42. So we got the Golbat today. That sounds right, because yesterday was the Zubat. Let's check out the Golbat sound. Jeez, I didn't know. I don't remember Golbat being like that. That's kind of sounds a little freaky, to be honest. Like, let's check out another one. That sounds more like a Golbat. Check this in one more time. I don't even know. But yeah, that was cool. So yeah, let's check out our problem of the day first. Maybe it's something pretty simple. Dude, man, that white stuff killed my eyes, dude. Yeah, look at us in February, man. We've been on the grind each day, so that's good. Oh no, wait, no, that's the problem of the day. Oh yeah, we did this problem of the day. Find the number of distinct colors among the balls. Maybe we might do both these problems here. I don't know. Design a number container system. Alright, let's check out this problem. Design a number container system that can do the following. So to replace the number at the given index in the system, return the smallest index for the given number in the system. We need to implement a number containers class. We need to do a change method. We need to do a find method that returns the smallest index for the given number, or minus one if there is no index that is filled by the number in the system. They give us a class here and a few methods. Interesting. So I think here, the start here, I think is we want to make a dictionary. I guess we can initialize it like this. Probably looks better. The reason why I kind of think about doing the dictionary here is that I feel like it's pretty obvious. It's I mean, we're looking here for an index and a number. And, I feel like a hash map is perfect for that. I mean, it holds key value pairs, so I think definitely that's the way to do it. Fills a container at index with the number. If there is already a number at that index, replace it. I feel like that's probably the same thing, so my_dic, my dictionary with the number, fills a container at index with the number. So I guess our index is going to be our key in this case. My index is equal to the number. I think that's it for that one. Then we're going to return the smallest index for the given number, or minus one if there is no index that is filled by the number in the system. So I think here the way that we want to do this would probably be some sort of for loop that loops through the items in our dictionary and gets the number, returns somehow like some sort of for loop that returns yeah, I don't know, something like that. Some sort of for loop, and we're going to loop through mydict.items, and if the value is equal to the number, then we're going to return that number, and if not, we'll return -1. Let's just start with that, and then we can kind of make some guess we'll do for I in _dict if _dict item. Wait, for I in, sorry, we need to do items. I guess we can do for key value in _dict.items. I think that's the way we do it. We can look for, well, if our key is equal to number, then key is equal to number. Sorry, wait. Returns the smallest index for the given number. Well, then let's just like return the key. Else, we'll return -1. Let's see how this goes. God, I have a headache. Minus -dict. Oh, we need the self keyword. We need the self keyword here, I think. How am I meant to know what's wrong? Bro. Yeah, I don't know. Let's check here how we can. I'm not sure how we can design this for loop here. Maybe it's probably something wrong with this. Because here we're looping through our key value pairs. We're only looking for the key. So we obviously need to find the smallest index. So I guess we need to kind of have like a, I don't know, some sort of like for loop to check. All the indexes. How do you do that in Python, man? I can't really remember. I think we can. I think it's called like list comprehension or something. I think in Python. Provides a concise way to create lists based on existing iterables. It often more readable and often more efficient alternative to traditional lists for constructing lists. So we do new list is equal to expression for item in iterable if condition. I think that, yeah. So if we do, let's just call this list res. That'll be fine. Expression. The value to be included in the new list potentially modified from the original item. I don't know. I guess we could just call it I. I'm not really too sure. I for item in iterable. I for... I don't really know how this works. Oh my gosh, dude, my headache gets so bad. You know, I'm not even gonna do list comprehension, just because it... For x times 2 for x in range 10. It's too much thinking for me right now. I need to warm up a bit. So we're going to go back to a normal for loop. We're just going to do it normally for key value in self.mydictionary.items. We're going to look for, well, let's go back. What do we do? If our key is equal to the number. I'm gonna think about the way how we can do this using this comprehension. So how can we look? Actually, we can kind of do... They're telling me to use a flag, so we can do flag is equal to true. Flag is equal to true. Oh, sorry, flag is equal to false. We want to create res to return here, right? I'm going to set this to an infinite value. How do we do this again? I think it's like inf or something. Float inf, I think. This is where we're going to store our values. So we're going to do, well, if we see this, we're going to update our res. So our res is equal to, we're looking for our min, so we can do min res. And then, what's the value here? Man, key dot value or something. Maybe we can just do key for now, I think. And obviously we want to update our flag, so we want to do flag is equal to true. Oh my gosh, dude. I guess now we can do return res if flag is equal to true, else we can return -1. Let's try that. Expected to let me just see if this is good. What's wrong with this? See, I know it's this loop because we're expecting a 2 here, but we're returning -1, so we're coming through this loop here. And it's not properly finding this number, so we're not... that's what we're doing wrong here. This should be value. Stupid me. Because we're looking for the value. There we go. Nice, bro. First problem. Hopefully. Oh, it passes. Doesn't look like it's going to pass, though. Ah, man, there's something wrong. What did I do wrong, bro? Bro. What the hell is this, dude? Jeez. What did I do wrong? What did I do wrong? Bro, how am I meant to know what I'm doing wrong? Like, huge test case, bro. Bro. What am I doing wrong here, dude? Dude, I don't even know what's wrong right now. What's wrong? Okay, well, it's telling me that my code is too slow because of the Boolean variables. So maybe we can just get rid of these. We can just return, well, we can return res. Res if res does not equal let's say does not equal 0, but it's not. It's always not going to equal 0, so I'm trying to think. Well, I guess we could just do does not equal this. Health minus 1. I think that's maybe this will make a difference. I don't know. I don't understand how that affects the time complexity really at all. Maybe it's because we're running this with so many. But I don't. Again, it doesn't work, dude. I don't know. I don't know what I'm doing wrong. Oh, I guess we're looking at a solution. What am I doing wrong, Mr. Rahul Vijayan? Bro, jeez, dude, like. Dude. Why are we using a heap, dude? Is this AI? Doesn't pass with Python 3. Syntax line 7. Bro. God, my headache's getting worse, dude. Jesus. Why do I feel so bad, bro? Like, dude. I'm just gonna try running this in Python. Maybe it'll pass. I don't know. I don't understand why. Bro, like, if I have to implement like a heap or whatever, bro, I'm like, that's why I don't. Maybe there's more to this problem. Like, that problem just seemed way too easy to be like a medium problem. Like, so maybe there is more to it. Let's try running it in normal Python. Okay, let's see if it passes. Bro. Dude. Man, dude, bro. This is such a stupid problem, dude. Like, you clean up. What is this guy doing? Like, bro. Okay. Okay, let's take a look at what's this guy doing. So he's initializing a hash map here, and then he's initializing a hash set, I think. Is it a hash set or is it? No. Bro, is it a hash set? Maybe it's just a list. Next number. Heap push. Number 9. Extra amount of loss. Code using push heap, pop heap. It's a dictionary default dictionary default dig. I'm a little confused here. Too much thinking for such a simple problem, bro. Like, the collection model is a dictionary-like structure that automatically assigns a default value to a key when it's first accessed. If that key isn't already present in the dictionary, this behavior eliminates the need to check for a key's existence before accessing or modifying its value, which simplifies the code and prevents key error exemptions. I didn't know about this. I guess you learn something new every day. So what is he doing here? He's checking his dictionary, has a number, then he's pushing it, self.index, number, index. Honestly, bro, I have to relook at heaps, bro. I don't understand what he's doing here. Like, self.index number. We'll come back to it. We'll come back to it. I just want to see. So they're doing the same thing. think my do I really want to watch this guy's video? I don't know. Maybe we might just watch a Leetcode video. It's a little easier for me. I can relax and watch a good Leetcode video. Why we need to use a heap design a number container system. Leetcode did not do one. That's not good on Leetcode. We'll take a look at this one.
Welcome back to TechDose, and in this video we will look at design a number container system, which is from Leetcode number 2349. Let's now look at the problem statement. In this problem we are asked to design a number container system that can do the following: insert or replace a number at a given index in the system, return the smallest index for the given number in the system, implement the number containers class in such a way that number containers initializes the number container system, void change index comma number fills the container at index with the number. If there is already a number at the given index, then we need to replace that number. The integer find with the given number returns the smallest index for the given number, or it will return -1 if there is no index that is filled by the number in the system. So if you look at the first example, in this case the numbers container is actually the initializer for the number container system. And after this, initially we have not inserted any item and we are trying to find 10. So if you try to find 10, then it will return -1 because there is no 10 present, right? Actually there is no item present. Now we are implementing change 2 comma 10. So what change was giving? It was giving at what index what number will go. So let's say at index 2 we have number 10. Okay, so we have applied that by change. Again we are calling change, so it is saying at index 1 we will have number 10 as well. Now we are again calling change, saying that at index 3 we will have number 10 again. Again we are calling change, at index 5 we will have number 10, and now we are calling find for 10. So the find for 10 should return if 10 is present or not. First you have to check it. Okay, yes, 10 is present, at least one 10 is present. Then out of all the options you have to return the one with the smallest index, and that is why it is returning 1 as a result. Okay, the change will not be returning anything. It is a void function, as you can check here. Now if you again implement change, then it is saying that at index 1 you replace the value, change the value to 20, and then again you are finding for 10. Now you check if 10 is present. Yes, 10 is present. There are three 10s present, and they are present at index 2, 3, 5. Out of all these available options, which one is smallest? The 2 is smallest, and that is why 2 is the result. Okay, so I think this problem statement should be clear. Now let's look at the constraint. In this particular case, the index can range from 1 to 10 to the power of 9, as well as the number range is also the same, but we have at max 10 to the power 5 calls, which will be made in total, combining the change and the find API. Okay, now let's look at the goal. We are given two APIs, the change and find. In the change we are given the index and the number, which indicates at the given index which number to be saved, right? So we will be saving at index IDX, we will be saving the value number, right? Now if you want to implement this, we certainly have two options. One way is to go with the hash map technique, and another way is to use the array technique. In the hash map technique, you can go with the simple KV pair, where you can keep the key as the index and the value to be the number. So simply whenever you are giving, let's say, change 2 comma 10, then you can insert it into the KV pair saying 2 comma 10, right, where key is the index and the value is actually the number. Otherwise, you can also implement it using the array implementation, where the key will be the array index and the value will be the array at that given index. So if you want to implement this 2 comma 10, then you can take a large enough array size, and so at index 2 you can insert the value 10. So this will act like a key, and the value will be actually the element which is stored in the array, right? If you want to save this at index 5, we need to have value 3. At index 5 we need to have value 3. So store 3 at index 5. In the map, simply you can just provide another entry 5 comma 3. Now if you look at these two techniques, then basically in the hash map technique, it is actually space efficient, because the space complexity taken by the hash map will actually depend on the number of entries exactly present. But if you look at the array technique, first we have to define the max size of the array, and you know that from the problem statement the max size is 10 to the power of 9, because the index can range from 1 to 10 to the power of 9. So you will end up making maybe the array to be of size 10 to the power of 9, and therefore you might not use all those indices, because maximum calls are only 10 to the power of 5. So the entire array will be very sparse, and it is a space inefficient technique, right? So can we actually use array? Well, we cannot use array, and the reason is the index and number both are in the range of 1 to 10 to the power of 9, and so the max index range is 10 to the power 9. So if you think about what is the integer size, if you take it to be 4 bytes, then the total space taken for 10 to the power 9 size array will be 10 to the power 9 times of 4 bytes, and you know 10 to the power 9 is 1 g, so you can just multiply it and get 4 GB space. So that will give you definitely a memory limit exceeded. So that is why we will not be going with the array technique, but we will be going with the hash map technique. So in order to save all the values at a given index, we will be using a simple KV pair, where the key will be the index and the value will be the number. Okay, so we got an idea of how to implement the change. Let's now look at how to implement the find. Well, for the change, we had seen we will be using the hash map with the index as the key, and the value will be the number that will be stored for the given key. But for the find operation, it will try to find, given a number, at what smallest index is that number present, and if that number is not present, then we need to return -1. Okay, so if I want to search by number, then I should have key based on number, right? But previously the hash map which I have created is having the key based on index. So how can we search based on number? So we need an inverted map, where the second map will be having the number as key and the index will be the value. Now if we do this kind of implementation, then we'll be take a simple KV pair. Now in this case, if you look at an example, and if we call the change 5 comma 2, then in the first hash map, which is for index number, I will call it just the index number hash map. In this particular case, you can just save that at index 5 we need to store value 2. In the second hash map, I will just call it number index, because this is just the inverted map, and in this case number 2 is stored at index 5. Now let's say I check the second constraint as well, which is at index 3 you have number 10, and the number 10 is stored at index 3, and the third constraint is at index 4 you have number 2, and here the number 2 is stored at index 4. So this will be overwriting it, right? But you know that according to the problem, there can be multiple same numbers present at different indices, and that is why I cannot just take a number index, but we have to take a list of index instead of taking a number index. Okay, now let's say we have taken a list index, so I will be storing 4 here. Okay, because 2 is occurring not just at 5, but it is also occurring at 4, right? The storage is complete. Now if I have to implement the find, then it is trying to find if the number is present. Yes, if I apply find on 2, you can just check that the key 2 is present, so the number 2 is present. But our goal is not just to find if 2 is present, but also to find what is the smallest index of these two. So I will end up iterating through this entire list and finding out the smallest index value, and that can be in the worst case order of n if you do linear search every time, right? Even if you sort it, it will take even more time, which will be n log n, right? Otherwise, there is another strategy that you could have kept it sorted in such a way that you can just apply insertion sort, and that will be for every insertion it will take order of n. So it is not better than the linear search, right? So in this way, if you do linear search, then the find operation will be taking order of n time, and the change will take order of 1 time, because appending at the end of the list is considered order of 1, right? So can we optimize this solution? Well, if you think about it carefully, then yes, we can optimize this solution by using sorted data structure. Let's say you can use sorted set. Okay, we can go for sorted set. So if you insert this 4 comma 5 in a sorted set, you know sorted set is implemented with a red black tree, which is a balanced binary tree, or you can say a balanced BST, right? So in the red black tree,
Interesting.
the insert operation, the search operation, the erase operation, all these operations are considered log n, okay, because the height of the tree is log n. And that is why if you insert all these into a sorted set, then you can always get the minimum value in very less time, right? So if you insert it in a sorted set, getting the minimum value is actually getting the beginning of the sorted set, and that is considered order of 1, because that is the beginning item, the first item itself. But insertion and erasing the item will be log n, right? So I will be going with that idea. I will be using a sorted set, because that will be optimizing everything. So having understood all the design choices, let's now look at a dry run. So in this particular case, I will be defining an unordered map of integer type, which will be mapping the KV pair from index to number, and the second map will be integer to set integer type, which will be mapping the given number present at what all indices in a sorted set, right? So this is the first hash map, and this is the second one. Now let's try to do the dry run. So the change is coming on the given index 5, and the number is 2. So at index 5 we need to store number 2. So number 2 is present at index 5. Fine. Now let's say a change is coming for 3. Okay, so at index 3 the number 10 is present. So number 10 is present at index 3. Change is coming for 4 comma 2. So at index 4 number 2 is present. So number 2 is present at index 4. So 4 is inserted into the sorted set. Now we are doing the find operation. So in this case, the find on number 2 will actually be checking this entire index. So in this case, if I will be able to find that, okay, 2 is present in O1 time, in average time O1, right? So if 2 is present, then get the beginning item of this sorted set, and that will be 4. So 4 will be returned as an answer here. Now for the next query, a change is coming for index 3, and this needs to be saving a value 6. But index 3 is already present in the first map, right? This means maybe some other value is present. So yes, 10 is present. So what we have to do is, if we override this value 10 with a new value of 6, then this 10 will be lost. So we have to remove this particular index 3 from the second map. So in the second map, look at the value 10 and remove this particular index 3 from it. If you remove it, you see that this set becomes empty. And if the set becomes empty, you have to remove this entry altogether from the second map. Because maybe later in the find operation, you will see that this entry is present and you might not return -1. And for that reason, I will be erasing it altogether. Erasing is log n time in the red black tree. And now I will be saving 6 here. So 6 is contained at index 3. Now a find is indices, which is the inverted map. Now if you look at the change code, then here an index and the number is coming. So simply I have to overwrite that. If the index is already inserted, then overwrite. If it is not inserted, just insert the index with the given number, right? So first of all, I will be checking if the index is already present. That means if there is already a certain value, then what I will do is I will go to the inverted table, and for that value I will be removing this particular
so I understand why now. This is using a... Shit, where is the solution? Construct two maps. Okay, yeah. Yeah, we talked about this, the constructor. Wait, is this the video that we looked at? No, different video. Hold the list here. Equal number. Number not in self.idx. Just want to return -1. Right, then technically we want to look through this. So while there's something present, okay, here, so we're looping through the numbers here. So while there's something in self.idx number, we're making I equal to the number, and then we check in our original map, which holds the actual value, that if it's equal to that number, we return I. Heap pop self.idx number, return -1. So yeah, make this equal. Dictionary. Number 0. Number. I. Keep. This must be my dictionary. Man. let's look at this over here. Which is the God, man, what an interesting problem. Thought I had it like 20 minutes ago, and then actually didn't. So interesting. Let's take a look at a different problem. Interesting that we had to use two sets there. I mean, bro, I'm not that great of an engineer, so obviously I can't obviously think like that. That like obviously you're meant to use, a dictionary holding a set technically, and all this other bullshit. Like, I don't know that yet, so I guess something that I could get better at, I assume. But what is this? We want to do this on 2D array. I don't want to do that. Oh man. Let's pick a hash map problem really quick. Just do a quick hash map. Something fun. Set mismatch. Yeah, let's do this one. You have a set of integers s which originally contains all numbers from 1 to n. Unfortunately, due to some error, one of the numbers in s got duplicated to another number in the set, which results in the repetition of one number and the loss of another number. You're given an integer array nums representing the data status of this set after the error. Find the number that occurs twice and the number that is missing and return them in the form of an array. Okay. So how can we think about this problem? Yeah, so I think this is always going to be sorted. That's my original thing. I'm thinking we live through, right? We find the missing value. I'm trying to think maybe what else we could do? I don't know if this could work, but I'm kind of thinking that we could just store this in a hash map. No, it wouldn't work actually, no. So the way I'm kind of thinking about this problem is that maybe we can find the length of this and we could, this maybe sound like a stupid solution, but I'm curious. I don't know if this works. We could find the length of this array, right? So the length of this array would be 4, right? Length is equal to the length of nums, right? Oh, whoops, we need to print it. I don't know if this is a crazy way to do it. I don't know. Maybe this is stupid. I don't know. So, right, we have 4, right? Then we kind of loop through and we check, well, what's the number that is repeated, right? We can find that number that's repeated. Then how would we find the number that we need to put in? That's the thing. 3. Well, we're always going to know that the number that's repeated is the next number after that. I'm thinking we can use a hashy, right? We don't even think we need the length, right? We can use a hashy and we can check, well, we could loop for I in nums, if I in hashy, I in the hashy. Let's create our number 1 and our number 2 variables. This is kind of thinking a little bit out of the box. I don't think this is going to work, but I'm thinking if we're looping through this problem and it's only 2 numbers every single time, then, this would work. But I don't know if there's, could be multiple different numbers that occur twice. I don't know. It doesn't really say in the problem description. It says one of the numbers in S got duplicated. So then it's always going to be 2 numbers. So I guess we could go for I and hashy. If it is, then we can assign, that's our number 1. Number 1 is equal to I, right? Loop over nums and use hashy to find duplicated number, right? Then, well, we know that our number 2 would just be equal to number 1 plus 1, right? So then I guess we can return number 1, number 2. How about res here? Can we, maybe we don't even. Did this work? Oh no. I put 0, 1. I put 0, 1. What do we, okay, what's wrong here? Number 1 is always 0 in both cases. Oh shit, we're not even adding any values to the hash here, bro. What? Bro. Dot add I. I guess we'd have to check before, so it would have to be after, no? Oh, there we go. Well, that worked. Maybe. No. Not understanding the problem properly. We get number 2, right? How are we getting 1 here? How are we getting 1 here? I don't understand. Wouldn't this work? Number 2 is equal to number 1 plus 1. Bro, how does this not work for this case? Like, what? Dude, it's the same thing. Like, like, bro, what? I expected 2, 1. Oh. You're given an integer. Oh, okay. Find the number that occurs twice and the number that is missing. Well, I always thought the number that was missing was the next number. So it doesn't say that. One of the numbers in S got duplicated to another number in the set, which results in the repetition of one number, a loss of another. I'm so confused, bro. So how do we know if it's... This question, we have to find the element in the array which is repeated twice and the number which has to come in the place of the repeated number. May be sorted or unsorted. So do we have to sort it each time? I'm kind of confused how they do this. Like I've got kind of like a similar idea where I use a set and everything, but the way that they find the duplicate is so interesting. Like they're doing the sum of first n natural numbers, n times n plus 1 over 2. Oh, that's what they're doing. So I think what the idea is of this problem is that so they use the formula n times n plus 1 over 2, right? So in this case, case 1, what was that one from yesterday? We have 4 in this case, so 4 times n plus 1, 4 plus 1 over 2, which is the sum of first n natural numbers. Right, so this gives us 4 times, so 4 plus 1 is 5, 20 over 5, which is 4. Okay. Right, that's correct, yeah. So then they actually get the actual sum, right? Which the actual sum is every number in the list. So 1 plus 2, 3, 5, 9. So our actual sum is 9. Then we find our duplicate, which is what I did here. And then to calculate the missing, they do expected sum minus actual sum minus duplicate. So the expected sum is... Wait, hang on. We got n is n times, yeah, this is 5. Okay, yes, we got 20 here divided by 5 is 4. Okay, so I'm right, I'm not tripping. Okay, so we do the expected sum. So the expected sum, apparently 4, which makes no sense as of right now. 4 minus the actual sum. The actual sum is 9 minus the duplicate. The duplicate in this case is, well, in this case here it's 2. And that should be the missing number, so let me do 7 for what? This should be 7 for what? -3. 3 is the number that we're looking for. Why are we getting a negative though? Like, what? Okay, I think I'm missing something here, bro, but I I don't know. I think actual underscore sum minus duplicate. Don't need this. Need to do a length, right? So the length of nums. We have our set. We have, this is our duplicate. Then we have our actual sum, which is the sum of our numbers. And we want to find the expected sum, which is n times n plus 1 over 2. Right? Find our duplicate. Alright, our duplicate is number 1. I mean, bro, technically, this thing is 3. Let's print. Yeah, I must be so expected sum. We would print our actual sum. Let's print our, oh man. Four, 9, 10. That's what we got, right? So n is 4. We know that. That's the length. Then our actual sum is 9. 2, 4, 8, 9. Yeah. And our expected sum is 10. Well, we do 4 times 4 plus 1. 5. Alright, then 4 times 5 is 20. Bro, we get 10. How did I get, bro? I'm so stupid, bro. We get 10 here, right? For some reason I thought this was divided by 4. Like, bro, what am I doing? Okay. So now that's why that's 10. Okay, so then we do our missing is equal to our expected sum, which in this case is 10. 10 minus, so our expected sum. 10 minus actual sum, which is 9. And minus 9 minus our missing number, which is, sorry, minus our duplicate number, which is 2. Minus 2 is 7. And 10 minus 7 is equal to 3. Okay, I understand. It was the formula that we didn't get. I don't know. I just don't know these formulas off the top of my head, bro. Like, how would I know that the sum of the first and natural numbers is this? And then, like, bro, like, how are you meant to know that? Like, I don't understand. Like, yeah, I definitely think there's probably another way that you can do this, which I'm kind of thinking just the similar way that this guy's doing it, is that you know, in this case, in these test cases, they give you, like, it's always the sum after, but it could be the sum before as well. So it's like, I guess you could maybe find a different way where it's like, you find the expected sum that it should be, because technically, you know, it should be sorted, and you go 1 plus 2 is the expected sum, and then maybe you could minus that from, you know, you could find the difference of something using a different, you know, amount and find the number that you need. I think, probably. I'm not going to do it right now, but I'm sure there is, like, another way that you can do this. Like, well, obviously you do the same way. You'd find the duplicate here. Get the actual sum, and you get the expected sum. Yeah. Minus your actual number as well. Gives you the difference. So, I don't know. Yeah. Interesting. I gotta kind of think of stuff. I think my problem is that I think of stuff in like one test case. Like I look at the test case and I'm like, okay, like, you know, I'm gonna make this work, right? But it's like I should be thinking in terms of like all the test cases. You know, it's not always gonna be the next number. Sometimes it is. Sometimes the easy problems I think like can be the next one, but at least those medium problems you gotta think about all the different test cases, like, which is something I think I struggle at. Okay, we're gonna do one more problem. Wait, did I submit that one? We're gonna do, I don't know. Still a binary search problem. I think we should check that out. Let's do same tree. I remember we did this in the past.
Supreme suction at your fucking service.
How are we gonna look at this problem? So we're given two roots, two binary trees P and Q, write a function to check if they're the same or not. Two binary trees are considered the same if they are structurally identical, and the nodes have the same value. Well, let's try and recursively solve this using backtracking, right? So I think here, what do we want to do? While P and Q is, while P not none and Q is not none. No, hang on. Trying to think. Our base case. Our base case would be, well, you know, if P dot left and P dot right does not equal make out P is equal to first is equal to P, second is equal to Q, right? Oh, no, I mean, we don't even need to do that, bro. It's not equal to none. And Q dot left and Q dot right. It's not equal to none. Let's take a look at our old one that we did. Binary tree parts, this one. We want to check out. Oh no, we could just, let's check on the GitHub. Dude, what is going on right now? So you got a solution right here. It's better, it's black at least. A little easier to look at on the eyes. So I guess really we just need our backtracking function. We just return true and false, right? So I'll put in our node. As we do, well, if not node, then we just want to return. Right? Yeah. Base case. Did I do this in December? This can be much more simpler, I think. Like, I guess we can just check, well, if well, I guess if the current node that we're looking at passing two nodes, well, we can check, well, if first.val does not equal second.val, then we can just return false, right? Yeah, but then this is... we can do this, because if it's not the same, then we instantly just want to return false, right? So... we can do, well, if node.left node.left is not equal none. Then we want to check, well, backtrack, node.left, backtrack, backtrack q.left. Sorry, what is it? Backtrack q.left, q.left, right? If node.right not equal none, then backtrack p.left, p.right, p.right. Otherwise we can just backtrack p and q. Guess we can just return true. Oh fuck, I submitted. If not p, if not q, not true. I really have to go to the bathroom again. Too much water. If p.left is not equal to none and q.left does not equal none. If p.right not equal none and q.right is not equal none. Maximum corrosion depth exceeded in comparison. What's my bug here, dude? What's my bug? We got the base case right. Well, shit. If not. I guess we don't have to check, really, right? I mean, why would we have to check? We got all these ifs checking everything, so it's like we can just go to the next value, right? Doesn't like this, bro. Turn. Why does it not like val? I don't understand why it doesn't like val. Why are we getting a trivia error here? I think this is going to be before. I think that's the issue. Okay, that was the issue. So we had to check if it was number 4. Then we want to return Alright, I'll be back. Then we're going to do the iterative approach with... We'll just do DFS. I don't think it really matters if you do DFS or BFS, but we'll be back. Jeez. Ow. Man, that hurt. Ow. Okay. Okay. Let's do our stack-based approach, right? So, how are we gonna do this? Start off, we want to add our nodes, right? Add our nodes, P and Q. Looks good. So our stack is not empty. Our stack is not empty. Alright. Want to check, well, let's do our count val is equal to stack.pop. Alright. And obviously we just want to check, well, is our pop in this value, like I'm gonna do what was first and second. Go to stack.pop, well, if our first is equal second, then I guess we'd want to add our children, right? Else if first does not equal second, I guess we can just return false, right? Yeah. Sorry, no, we'd want to do actually, sorry, no, we want to do if not first or not second, which means if one is empty and the other one isn't. If one is empty and the other is not, then we obviously want to return false. And then, well, we'd have to check, well, if, I guess we can check these independently. So we can check, well, if first dot val does not equal second dot val, right? Yeah. I think we're good. Maybe just append. Stack.append. First dot left. Second dot left. And stack.append. Second, sorry. First dot right. Second dot right. We can just return now. Guess we get through all this, we can just return true, right? Takes exactly one argument to given. What? I'm confused. Maybe we need 2 parentheses. Oh, sorry. Maybe we need one of these ones. I don't know. Built-in functional method object is not subscriptable. Okay, maybe not. Maybe we need parentheses. What does not subscriptable mean? I don't understand what that means. I'm gonna search up that error. What does... Oh, okay. So, we have to use the parentheses apparently. Why do we get false for this? 1, 2, 3, false. Output true. What? Not first and not second. Let's see, both empty. What's this case? Why is this returning false? Oh, I'm returning true. Bruh. So is this needed? So this is needed. Yeah. Oh, okay. This is needed because, well, if one of them is empty, it's going to return false. You know, so we need to check, well, if both of them are empty, you continue. Yeah, because if this was over here, right, then this would still return false. I think. Yeah, that's what I thought. This is going to be before, so you can break out of the loop. Nice. Cool. Nice, bro. Nice, man. Alright, well, I'm gonna call it there, guys. I appreciate you guys watching. You know, I will see you tomorrow. for a little Sunday session. I'm gonna look for some food now to eat for dinner. So appreciate it. See you guys later.